Hello! In this video, I want to discuss how we would report the results from a simulation or experiment. In other words, I want to discuss one type of figure that we might construct when we write a report about a series of simulations or experiments that we have done. So that I am not discussing things in the abstract, I'm going to discuss this type of figure in the context of the model that we have been looking at in the last few exercises. This model that we've just been looking at is a model for a gambler playing a game. In discussing the model, we have stated that the gambler enters a casino with a certain amount of money and he repeatedly plays some simple game that he has a probability P of winning. We have used the graph shown at the top of this slide to indicate the amounts of money the gambler can have, and have noted that if he wins the game, he moves one step forward along the graph, and if he loses the game, he moves one step backwards. Lastly, we have insisted that the gambler will stop playing if he arrives in state 0 or state 4, as shown here. In previous videos, I have shown you how we can write a program to determine the number of times the gambler plays the game before stopping. Furthermore, I have explained that the quantity that measures the number of steps that are taken along this graph is a random variable. In this video, I want to point out that this random variable is also what we call a dependent variable. This statement means that the number of steps the walker takes along the graph is a function of some parameters that we can control. In particular, this dependent variable t depends on the following three independent variables: the initial state, k, the probability of winning each of the individual games, p, and the number of steps in the chain, n. Given that t depends on k, p, and n, when we come to writing up our results, we might want to try and show how t depends on one of the three variables. For example, we might want to draw a graph showing how t depends on k, as shown here. In such graphs, we would typically draw the independent variable on the x-axis of the graph, so that would be k in this case, and the dependent variable on the y-axis of the graph. When we draw graphs like this, we can speculate on whether there is a function that can be used to calculate the dependent variable from the independent variable. In this graph, for instance, it looks like t is a quadratic function of k. So we have some quadratic function, we can predict the value of t for a particular value of k. There is one important consideration that we must remember when we create graphs like the one shown here. This consideration is the fact that the dependent variable t is a random variable. We must therefore provide some information about the distribution of t in order to make our result reproducible. This is why the error bars are drawn in the figure. These errors indicate the 90% confidence limit on the estimate of the expectation for this random variable that has been computed by taking a sample mean. In generating this figure, we have thus had to do all the analysis that you've done previously for single means for each of the simulation results that we have obtained. In other words, we have had to run multiple simulations for each value of the parameter k in order to characterize the distribution for the random variable that we have obtained from these different experiments. As you can thus recognize, quite a bit of work goes into creating a graph like this one. Now see if you can reproduce this result by completing the exercise. Good luck, and thank you for your attention.